Welcome to the University of Iowa's Materials Analysis, Testing, and Fabrication Facility. Here at the MATFab Facility, we have a unique set of analytical instrumentation and fabrication equipment to meet your lab's research needs. Our facility has analytical tools for doing elemental and chemical analysis, imaging, spectroscopy, and more. We also house a fabrication facility for building micro and nanomaterials. We currently support 4 working lab spaces with over 30 pieces of equipment, 2 clean rooms, and well-trained staff with a diverse set of educational backgrounds such as chemistry, engineering, and geosciences. We are located over on the first floor of the Iowa Advanced Technology Labs, located at 205 North Madison Street in Iowa City, Iowa. For elemental analysis, we have an inductively coupled plasma, or ICP, optical emission spectrometer, and an ICP mass spectrometer. And these will determine elemental concentrations in samples, either those dissolved in an aqueous solution and introduced with a peristaltic pump, usually dissolved in acid, or via laser ablation techniques for analyzing solid samples as well, like minerals or glass. Our ICP optical emission spectrometer is equipped with an Shell polychrometer grating, which allows simultaneous measurement of the UV and visible spectrum across 70,000 pixels for doing elemental analysis in the visible region simultaneously from 167 to 785 nanometers. This system can measure samples down to the parts per million, from up to at highest maybe a few percent. Our new ICP MS, or mass spectrometer, is able to do stable element isotope analysis down to the parts per billion or parts per trillion, as well as doing nanoparticle sizing as an added feature to this new system. For organic or organometallic solids or liquids, our combustion elemental analyzer can analyze carbon, hydrogen, and nitrogen mass percents on samples of less than 3 milligrams to within 0.2%. Our new X-ray fluorescence spectrometer can do large spot elemental analysis on nearly the entire periodic table down to beryllium on both fused glasses, liquids, and powdered samples. For surface analysis, our lab is also equipped with an X-ray photoelectron spectrometer, or XPS. XPS is done at 10 to the minus 10 torr in vacuum and has surface selectivity of 10 to 15 nanometers. XPS is able to qualitatively determine the composition of the sample by doing X-ray spectroscopy for chemical analysis, and can be quantitative if proper analytical standards are available. In addition to simple spectroscopy, our Axis Ultra is also equipped with XPS imaging, a field emission gun that allows for scanning electron microscopy to be performed in the chamber, as well as OJ spectroscopy. We also have a helium lamp source that allows us to do ultraviolet photoelectron spectroscopy, or UPS, and an argon gun that allows us to analyze the composition of the bulk of material as the surface is etched away. Our XPS stage is also equipped with an X-axis rotation so that we can do angle resolved XPS as well. Our lab is also equipped with several optical microscopes, a Raman microscope, a scanning electron microscope, and a scanning electron probe microanalyzer. Our SEM is one of our most widely used instruments for looking at sample morphologies and uses secondary electron imaging as well, and on top of that has an energy dispersive X-ray detector for doing semi-quantitative chemical composition analysis. This instrument can also measure light being emitted from the sample using a cathodoluminescence detector that's installed as well. For more quantitative chemical analysis and elemental mapping, this can be done with the Scanning Electron Probe Microanalyzer. This uses a high beam of electrons much like a scanning electron microscope. However, it has 5 wavelength spectroscopy detectors that can capture quantitative information on elements from boron to uranium. This instrument also has a cathodoluminescence detector that can look at light produced by the electron beam on your sample in the visible range. In addition to our analytical labs, we house a state-of-the-art micro and nanofabrication facility as well. Users have access to an array of continually managed instrumentation for fabricating novel, micro, and nanoscale structures, which are housed in our combined 1,500 square foot of Class 100 light-filtered cleanroom space. Our instrumentation is also constantly evolving to keep up with advancing techniques. Developments at the MATFab facility include microfluidics, LEDs, CMOS arrays, plasmonics, microneedles, MEMS, optical filters, gratings, nanocoatings, and a variety of different electrical and optical sensors. To create these devices, we routinely use a variety of lithography techniques that produce patterns which span 8 orders of magnitude, from several nanometers to centimeters in size. These patterns are subsequently used to either deposit materials, such as metals, glasses, or ceramics, or to etch these materials with nanometer precision. The fabrication techniques available in the lab include photolithography, e-beam nanolithography, nanoimprint lithography, multiple plasma etchers, metal and dielectric deposition tools, and are all readily available for fabrication users. We also have multiple etching stations, grinders, and polishers, ovens, furnaces, dicers, and dedicated process fume hoods available for our users. Profilometry, optical microscopy, ellipsometry, and scanning electron microscopy are also readily available for characterization between fabrication processes. Our facility offers competitive rates with other core facilities in the country, as well as user training for a modest fee. Once users are trained to use the instrumentation, they have access to book the instrumentation at cost. If researchers choose, our staff are highly trained and well equipped to run samples for them at an additional fee. We have an automated booking system online for our users to use to book time and check instrument schedules so that users can reserve space for their research from anywhere on their phone to their laptop. With questions about how to gain access to the facility, please feel free to contact any of our staff or our director, Christopher Cheatham. Thank you for your time and interest in our facility, and we hope to help you with your research very soon.